Event sourcing and CQRS, command query responsibility segregation in Scala. So I want to talk about the basics, the fundamental ideas behind event sourcing, and then I want to show an example how to do it with, in Scala with a framework called Lagom Persistence. And I picked a very, well, I really wanted to get down to the fundamentals and sort of phase out all noise. So I picked a very simple example. What I want to achieve is I want to create a table like this. This is like a scoring table of a football league, right? So I want to see the teams in the league, how many games they've played and how many points they've accumulated through winning games. In a relational model, so that obviously that's pretty straightforward, and I could just set up a table in the database, and whenever a team wins, I just add 3 to the number of points they have. But I don't want to use a relational database. And there are at least 3 reasons I can think of why I don't want to use a relational database. The relational model and the models we use in our languages usually are not a perfect fit, right? There's always a mismatch. The structures we use in memory, trees, subclasses, hash tables, they don't have a clear representation in the database. There's always some weird mapping going on. So what we do, or what people used to do, is use object relational mappers, but they are leaky, right? This term, leaky abstractions, you've probably heard that. That was coined, I think, by Joel Spolsky, and it's about abstractions that abstract something away, but to use it properly, you still have to know what's going on underneath. If you use, if you've done that, if you used Hibernate, for example, you set up your model, and it's all very nice and abstract, and you don't have to care about the mapping in the database at all, then you run your application and you have a lazy initialization exception, right? So at this point, you have to think about, what happens underneath? When are the things actually loaded? And this can get complex very quickly and actually be a lot of noise in your project. This guy, by the way, if you Google ORM, you might find this guy. This is Orm Marius. It's the evil brother of Aquaman. And he has a very nice description on the Wikipedia page. It says, he started off as a pirate attacking ships, but then he went on to creating natural disasters. And this is the feeling I have when I use object relational mappers. And in the beginning, it's just mapping some classes, but it ends in natural disaster. Scaling, we all want to write scalable applications. We want to be reactive. We want to scale infinitely. The relational databases are usually about scaling up. If you need more power, you buy a bigger server from this guy, possibly. Scaling the reads of the database is not even that difficult. You can just run followers or replicas and distribute reads over them. But because of the transactional nature and the consistency guarantees of the relational database, you need some central coordination for the writes. So you usually have a central master that deals with the write side. If you overload, so if your master becomes too weak for it, if you have to scale the write side, that becomes very difficult. You have to do sharding, so you have to divide your data on different masters, and that's usually difficult with the relational model because you probably have some joins, and then you have to deal with, well, you have to set it up in a way that the joins don't span the shards, and and also you want to do this dynamically, right? You want to be able to add servers and remove servers at runtime. That's what we want to do, like we can do with Akka cluster. We want to be able to breathe and according to load, scale out or scale in, if that's a word. So that's difficult on the read side with relational databases. And then often we have business requirements that really don't match the essence of the relational model well. In relational databases, you have destructive operations, right? You can update stuff, which basically means overwrite something. Forget the old stuff, take the new data. Or you can delete stuff. Now, often people start with a very simple model. Say, okay, we have this nice relational model, and then sort of in the course of the project, they discover, actually, we don't want to delete stuff. We just want to sort of market delete it. So you sort of change the life cycle and say, no, we don't really delete, we just introduce a marker. Then they figure out, no, actually, I also want to see who changed this, so and when it was changed. So you create like life cycle columns. When was it created, who created it, when was it changed, and so on. And you might end up having a complete audit table, just tracking all the changes to one table, maybe using something like Hibernate Envers, which is all in good faith, and it's great work that people do, but it shouldn't be all this extra work, right? It should come more naturally. So if you want to keep the history of your data, then you shouldn't go through all these loops and hoops and have to do all this extra work to keep it. And there are actually quite a lot of use cases where we have this, also like in real life or in programming. We have a lot of scenario where we want to keep all historical data. Maybe we can make this a bit interactive. Maybe somebody can think of an example, something where we want to keep the sort of the all changes historically and never throw anything away. Sorry, account balancing? In a bank account, the account balancing, yeah. I guess that would be, if my bank would just tell me your account balance is €1,000, that would be, I would be curious, like how I thought it was 2,000, how did it come to be? So the balance will always be the result of the transactions that happened, right? And my bank statement will always show what came in and came out, and it's actually this flow of events that creates the balance. Another example, so a very technical example, would be version control in software development, right? We don't just replace, obviously, versions on the server or in our GitHub repository. We keep the history. We can see all changes that we ever applied. So bank statement was already mentioned as an example. Cargo tracking. Oh, sorry, that was too quick. Cargo tracking is something where sort of the events are much more interesting than the actual state. Like the state is true. It's either I already have it, then I know the state, it's there, or I don't, and it's either in transit or it's lost. Okay, that is a bit interesting. That's the difference between this. But usually, you want to see, you get these tracking points. They're scanned at certain hubs, and then you can see the flow of the cargo, and that's what you're interested in. Or this is supposed to be like an accounting ledger in a firm. In accounting, there's the saying, accountants never delete, or they don't have an eraser, I think the saying goes. Because I think you're not even legally allowed to do that. Like if I send an invoice to somebody and they book this invoice, and it's in their books, and then I realize I made a mistake, and actually I get less money or whatever, I cannot just say, oh, please undo this invoice, and let's change the amount there. I have to write another sort of cancel invoice, or an invoice cancellation. I have to write a new invoice, because it all sort of, you can only sort of you can cancel bookings and you can have compensating bookings, but you cannot just go back in time and pretend something didn't happen. Because that's also how life works. That's how time works. Time goes on. We cannot just go back in time, and sometimes we wish we could probably just undo things. But also in real life, when something has happened, it has happened, and the time goes on. So this is actually something I can talk about for hours. So one of the issues, if you're used to using the relational model, then it can become a bit more difficult to go towards an event source direction. But I think for me, that's part of the fascination of it. When I think back, so computer science is great, programming is great, because we always learn new stuff. There's always something new to discover, new libraries, new frameworks like Lagom, or new technologies. But the most interesting bits for me are the ones that actually make you unlearn something. It's not only about the learning. When you learn something, you sort of put it in place in your world view, and you say, okay, I learned something new, it fits in there in this place. Sometimes you learn something that actually contradicts something you learned before, and you have to unlearn. Maybe if you've done a lot of imperative programming, you learn functional, you feel like, okay, if I just apply the patterns that I'm used to in this new paradigm, that doesn't really work. I have to change my mindset. I have to unlearn what I've learned. If you go from sort of sequential programming to working with actors and messages, you have to unlearn. If you go from relational to an event-sourced approach, you're going to see that the technical part is actually more or less trivial. It's more the mindset thing, unlearning what we're used to. So forget the data model. It's also something I don't know if it's just me or if it happens to everybody, but often when we're designing systems, when we're discussing systems and system design, system architecture, we jump to the domain model and sort of static representation of our domain and data structure so quickly. We really very fast, we start thinking about the entities we're going to have and sort of their structure, rather than focusing on the dynamic properties of the system. What events are actually occurring in the system? I think this is a trend now, that people change the way they design systems. And in this whole domain-driven design community, and especially if you do something like event storming, you don't think about, actually you try not to design your data structures at all almost. It's more about following the events that happen in your system, and then you hope, or you work towards the boundaries emerging, right? You figure out, okay, to process this event, whoever receives this event also needs to know this, and it has to have a certain knowledge to maybe to validate something that comes in. So there's a boundary where I have a cohesion, where I have to put things together. But it's actually, this event can be processed without knowing of anything else that happened in the system, so there's a nice boundary there. Although, if you start from a static model, maybe you would have put it into one. So going towards event sourcing is a lot about, or can influence your style, your design, way beyond the actual coding, right? It can also influence, can sort of back-propagate towards the design process and your approach towards thinking about the system. So if you haven't, I really would recommend that you check out, that you just Google event storming and so read a bit about it, and if you have the opportunity, try it out. So back to our little league application. So I don't just want to sort of have this table and just set a number of points, because I now realized that whatever is represented in this league table, whoever is the first or the last or on whichever position, wherever they are is the sequence, is a result of events that happened. And what's the event that happened? Well, a football game was played, right? In this case, my favorite team had a great win, a thoroughly deserved victory, but unfortunately it was one of few in that season. But, and this is what occurred. This is also interesting. What is the event? So if we, again, if we think in our sort of traditional ways, sometimes we have too fine-grained or too technical events. Like if you have events like change this property or sort of, then that's probably not a good event. The event should represent something that actually happened. Right? Like it should be a business event, something like not sort of an event change the address field, but have an event the customer moved. That's the event that actually occurred. What is an event? An event is something that happened. That's going to come back to us later. So it's kind of undisputable. There's like no point in if an event happened, there's no point in sort of validating it and see if it sort of fits into your model because it happened. An event is a fact at a certain point in time. There's no going back, there's no challenging that. It's kind of undisputed that it happened. Just like in the real world, yeah. But how do we implement this? So we have to break it down a bit further. That's a bit too magic. We say, okay, these events happen in the real world, and we're just going to sort of aggregate these events somehow, and then we have some state. Of course, we have a program where things come in, and we have to capture the state somehow, and we want to track these events. So if we break this down a bit, we're going to have some commands coming in, right? So that would be a user interaction, for example, or a request to your web service, and that would express some intention. It would say, in my case, that would be maybe we caught this game. This is the result of this game played. Please track the result of this game. Please add this game to the table. And I'm going to send this event to something. This could be, maybe Aggregate is maybe the best name, sort of the most neutral name for it. So domain-driven design, people would call it Aggregate. In Lagom, it's called persistent entity. In Akka, it would be a persistent actor. So let's not focus on the name so much, but we have something that receives the event, that receives the command. If it can process the command, if it's a valid command, it will accomplish or emit or whatever an event. And this event will be recorded. We're going to store this event so we can replay the events later, and it will modify the state. So this is the same entity, this yellow thing, right? It starts off in state A, an event happens, it's going to have a new state. And so the nice thing about this, now I'm going to show how this is coded with Lagom Persistence, part of the Lagom framework. And I chose this as an example because if we have this picture in mind, we can literally just sort of automatically translate this in Lagom constructs. We have classes for commands, for events, for the state, and the framework will take care of tracking those events. So I think next we're going to look at some code. Yeah, it's a really, well, obviously it's a simple example. I don't know how interesting the code is, but if you want to look at the code on your own machine, that will be the GitHub repo for the example for this talk. Let's see. So remember this, we have a command, we have an aggregate, it's going to emit events, and it has some state. So let's look at the command first. I don't know how familiar you guys are with Akka persistence, for example, or with other, with Akka actor messaging and so on. So I'm going to point out some differences to Akka. If you don't know Akka, don't worry about it. It's not important. If you know Akka, you may or may not find it interesting. So the commands are messages we send to our aggregates. And you see here, well, they're just simple case classes, right? They're just like actor messages or anything else. You just use a case class to send your command. It has to be serializable, obviously. We want to send it over the wire. We also want to be, well, in this case, we don't want to store it. Maybe interesting here is that we have to extend this trait here, reply type. So when we define our command, this is like a little Lagom thing. When we define our command, we also define what the type of the answer to this command will be. This allows the compiler to do some additional type checking. So at the point where I send the command to my aggregate, I already know the type of the result, and so I can process it in a type-safe fashion. But that's really, so in my case here, these are just this data is just posted to the service, so there's no payload that's going to be sent back. We just acknowledge the command, so we just say done when we process it. Also, we're going to define a couple of events. Again, very straightforward, just case classes, right? Each event, again, you have to have a sort of a common super type. And the one thing that we're also going to come back later is the tag. We're going to tag these events. Because, well, yeah, we'll come back to this later. Just keep this in mind. All these events, they share a common tag. What's next? I don't know. Oh, yeah, and then the state. In this case, so what do you keep as state? In your aggregates of at runtime, well, you need to have the stuff that you need to validate the commands, right? So here you can see the state is much simpler than the result we want to see in the end. We want to see like a sorted table with the points and so on. At this point, we just keep a set of the games we already know. So we just want to validate if there are duplicate entries. If I'm told to record a game that has already been recorded. Or if somebody wants to add a club to the league table, but it's already, there can only be 18 clubs in this, or in this model there can. So we have to keep track of the clubs we already know and of the games we've already recorded. But in what sort of, there doesn't have to be any structure to it. We just need this to validate the commands and to check for these validations in our set. So yeah, maybe, let's look at our aggregate, or our sort of persistent entity. So in Lagom, Lagom prescribes a certain structure for this implementation. That is what makes it so easy as well, so that because it guides you. As I said, if you look at this command, my aggregate, the events thing, you'll have sort of immediate representations in the Lagom framework. And you actually have to configure your persistent entity to know about these. So you have to define these types. You have to tell it what your command type is, what your event type is, and what your state is. Initial state is just sort of setting it up. And then we define the behavior, pretty much like a receive block in an actor, but it uses slightly different mechanics. And here we have, we define command handlers, right? So whenever I get a add, so I don't know if you read that carefully, you've seen we have 3 commands: add a club, add a game, and change a game. So I can add a club to the league, I can add a game. Actually, if I add a game and the club is unknown, then it will just automatically, oh, that's what we're going to see in the code. So I can add a club. I will validate if this is, I'm going to scroll down, very simple validation. I'm just going to check if the club is already in my table. Then I say, no, this is invalid. It's a duplicate entry, and I'm going to emit an error. Otherwise, I'm just going to add the club. So validate the command. If it's fine, no, if it's an error, if it's an invalid command, just reject it. And otherwise, I want to persist an event. So my validation gives me back either an error, well, it gives me back either an error message, or it gives me back an event or a number of events I want to store, the events that I accomplish. So in this case, if everything's fine, I want to emit this club edit event. So I want to persist this event, and then I can do some other stuff once the event is persisted to, for example, replying back everything went fine. That's basically what we're doing here. So if I add a game, you can see, okay, here in the validation, one command can result in a number of events. It's not a one-to-one relationship, right? So if I add a game and I say, okay, these clubs have not been added, but for convenience, I want to add the clubs automatically, I can just say, okay, check the game, are the clubs already known, or is the game already in there, then we just reject it, otherwise see if the clubs are already in there, otherwise create a sequence of events where we add the clubs that are new to the system and the game. And I also have a change game thing. Well, I said we just want to keep a log of events, right? We don't really want to change. I said events are facts that happened, and we can't go back and undo them. But maybe I recorded a wrong result, and I need to change it. So this business case, of course, can happen. In an event source system, what I would do is I would have a cancellation event. I would say, okay, in this case, I would just sort of create an event, result revoked. I would say, okay, this previous result actually has become invalid, and I will add a new game afterwards. So, yeah. You see, it's pretty straightforward. So this is how the commands are handled. And the command doesn't really change, the command handler didn't change the state at all, right? It just validates the command. Maybe it does some other stuff. Maybe it sends some message somewhere, or I don't know, does some side effecty things. And then it will emit events. But it doesn't touch the state. For this, we have the event handler. So in my behavior, I process the commands, and I define an event handler to handle the events. The command handler validates the command, emits events, and the event handler changes the state. Do you see, again, these are super trivial. They literally just create a new copy of the state with the changed state. This is on purpose. You don't want to do much stuff in the event handler. Really, the things you want to do is create a new version of your state. Or things you certainly don't want to do is you don't want to have any side effect or sort of user affecting operations there. Because when we restore an entity, so the way we're going to look at that, but the idea of event sourcing, of course, is when our entity in memory crashes and has to be restored, we're going to replay the events to recreate the state we had before. And this event handler is going to be executed on the recreation of the events. So this will all be executed every time we basically recreate our entity from persistent storage. So you don't want to do these side effecting things every time. Also, what you don't want to do is any kind of validation there. As I said, there's no point in validating an event. It happened. There's no point in sort of disputing it and saying, no, this event is invalid now. There's one other thing you could do, or that's meaningful to do in the event handler. That would be, but it's not in this example, that would be changing the behavior. An entity like this can also be like a finite state machine, right? You get a certain event, you change your state, but you will also change the way you react to subsequent events. Maybe at some point, maybe it's a process like a contract that starts with an offer, then it has to be confirmed or accepted or anything. Maybe at some point it's closed. And events may have different transitions and different events initiating these transitions in different states. But as I said, it's not in this example. So pretty straightforward, eh? Yeah, just for not to leave anything out, we need some sort of service to send the commands to our implementation there. Again, very straightforward. It's I have a registry of all my league entities. In this case, just one. I just created one for the Bundesliga. So I'm going to take the key for it, get this entity, and then I use the ask pattern to send a message to it and get the reply back. Little side note, this is not the usual akka ask. This is Lagom's ask, which actually sort of automatically casts the result to the expected type. And this is what I said, this is one of the points where it comes in that we define the reply type on the command. Because at this point, the compiler can check that the result of this, well, in this case, it's just done again, but the compiler can check that the result that I return from this or that I expect here actually matches the type that I declared in my command. So you get some additional type checking there with Lagom. And you could say it's poor man's akka typed. And lastly, of course, I have to define some URLs where I can post some data. That's the service descriptor, or it's a Lagom thing where you sort of separate the service implementation and the service descriptor. You see it's a very simple routes definition. Just say, okay, I can post this, I can post a club game, or I can use a put operation to change a game, and then the appropriate server is going to be invoked. Okay. Let's see if we can start this up. Starting a Lagom application, luckily, is always very simple. You start SBT and you say run all. Ding, 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 ding. Oh, I use Cassandra to store the events. Oh, yeah, we can talk about that later. It's also the default in Lagom, so it starts up Cassandra automatically. Oh, should be compiling. I don't know what change that was there. So now it's running. Let's connect to the Cassandra. It already created, so Lagom will also, just like Lagom Persistence, will automatically create sort of the structures we need in our Cassandra database. Right now we can see it's empty, or well, almost empty. There's also some state of some of those like coordinators that Lagom uses. The state of those is also persisted in the database. Now I can put I have some JSON data here. Very simple, the team. I just took the results of the first game day of that league, and oh yeah, somebody won 6-0, and I can just post this to the service. As I said, the payload is just, these are just post requests, just get an acknowledgement, so there's no interesting result. But now, we can see that our system sort of processed these commands and recorded these events. So this is what's going to end up in the Cassandra database. These are the events that we emitted, right? You can see, and there's the payload here. This is the, okay, this doesn't scroll so nicely. This is the club edit event. This was the actual name of the club. And then so we added the game there between these two clubs. And yeah, and that's basically it. So now we have, rather than having this table with the scores and the teams, we have the sequence of the events of the games that have actually been played. Let's go back quickly and then compare this with the previous approach, or with the relational approach. Let's quickly talk about how this works. You saw this, maybe you saw this line, get the reference. I'm going to quickly go back to that. What happens here? So we have a registry for entities, and we get a reference for one. So what it uses underneath is Acker cluster sharding, right? And the idea is that rather than using system actor of or this sort of using actor of to get a new actor, I go to a registry, I go to a repository, and I say, give me an actor for this key, right? And I always get back an actor. And the actors, so I can create millions of those. I can just ask for more actors. And in a cluster, Acker cluster or Acker cluster sharding will take care of distributing these actors in the cluster, right? It's cluster sharding. So it creates a number of buckets and then puts the actors in there, and then it can distribute these buckets in the cluster. An interesting point of this is, so there will always be only one of an actor with a given key, right? So although it's a distributed system, if I'm on node A and I get a reference, or I go to node B and get a reference for the Bundesliga table, for example, I would just get the actor ref to the one entity in whichever shard it is, right? This is very interesting from a consistency point of view. So I cannot have diverging instances of my league. I cannot have two instances that process commands and maybe diverge in their state. It will always go to the very same entity. Right? So that's how Acker cluster sharding works. It guarantees this uniqueness. It gives me dynamic redistribution. I can add nodes. I can remove nodes. One thing that if you haven't used Acker Persistence, one thing that I found remarkable when I started using is that you don't have this idea of, like in a relational database, where you do a select and either you have a row with this key or not, and you either get a result back or not. With Acker Persistence, you give it a key, you will get back an actor for this key. Then, when this instance is created, it's going to check, are there events related to this entity? If there are, they're going to be replayed, and the state is going to be restored at whatever state it had before it was passivated, before the node crashed or whatever. So the state is kept in memory, it's persisted, it can be restored, but you will always get an instance. So in another CQRS framework, you actually have a method to check if the instance is new, it's like uninitialized, or it already has associated events. So that's something that might affect your programming style there. So it uses Lagom Persistence underneath, it's scalable, it's Trance. It will always give you an instance, and will always also manage the life cycle of your instance, right? So it will keep the state in memory, but only as long as you use it. If you don't use it for a certain amount of time, it will passivate this instance. Basically, passivation basically meaning expunging it from memory, right? Evicting it from memory. If you use it again, it will recreate it, it will activate it. So it will just, the process I just described, it will create a new instance of it, it will look for any events associated with this instance, will replay these events to restore the state. And, well, if you have a large number of events, of course it can take some time to restore the state. If you have thousands and thousands of events, those would all have to be replayed. So to optimize this activation, it will also take snapshots. Every 100 or so, I think, events, it will take a snapshot of the state. If you remember, our state class was also serializable. The state will be serialized in another table, in a snapshot table. Comparing this with the relational approach, so in the relational approach, we had this impedance or impedance mismatch. Here, if you remember this image with the blue arrow and the yellow thingies, this is the one-to-one mapping to the constructs we have in Scala or in the Lagom framework, right? The commands are commands, the events are events, or the commands are so actor messages, the events are events, the state is the state. There is no mismatch there. That's totally straightforward, great alignment. In terms of scalability, as Akka cluster grows, you can scale it basically, well, infinitely, that's a big word, but I think Conrad yesterday talked about an Akka cluster of 2,400 nodes or so that somebody ran somewhere. So you can literally scale it to thousands of nodes. So you can scale your right side, you can chart your right side, basically with no limits. There's no single point of failure, there's no master for coordination. So it's highly elastic, and it's highly resilient, things can crash. Instances on a node that crashes can just be recreated on some other node. Nodes can be added, nodes can be removed. And as we saw, all the events are always kept. So we'll always have the complete history, the complete log of events. So it's append only, so it's actually also very efficient, right? You don't have these destructive you don't have these destructive operations, and you don't have to modify kind of in place. You could basically use a file to log all these events because you're always only going to append. They're immutable, no destructive operations. Cool. So that's all very fine, but actually we didn't get to actually seeing this league table yet, right? So we just have this log of events, but this is not what I want to present to my user, or this is not what I want to see myself. I need to have some view of the data too that actually shows me the table. So with event sourcing, it's usually a good idea, or it's actually the only possibility. The idea there is to just keep it separated completely. You have this one, like the German motorway, or maybe in Denmark it's the same. You have the two lanes going in the one direction, the right side, and you have a completely different separated direction, different lanes for the different directions. So we're just going to keep this completely separate. In my example here, we're going to use a completely different database even. And this concept, you can use this also without event sourcing. This is called command query responsibility segregation. To build this in Lagom, we consume the stream of events. So we're going to read from the database and consume the events as a stream. So we're going to kind of continuously read, process the stream, and use the stream to build the read side. Lagom has built-in read side processors, a Cassandra read side processor, and a JDBC read side processor. Unfortunately, as far as I understand, they don't really support this use case quite yet. So you can't really, they are great, or they make it really simple if you use the same database for events and your read side. But in our case, we want to use a separate database. So I built this little read side here. I built this little projection here, sort of basically an actor well, it's still simple, right? It's not completely built into Lagom, but with all the things the framework gives you, it's still super simple. You just get the sort of the session for the read journal. So you can get your Cassandra session from Lagom, and then you just use the events by tag. This is a sort of an Aggregate persistence query thing, right? You get this persistence query, and it has an events by tag method. This is where the tags come in. If you remember when we defined the events, we tagged them. So this is how we can get all the events that are associated with a certain type of entity, right? Because these can be different types of events. You cannot just use the event type. So this is our way to find out which events we're interested in. This is why we tag them. So I'm just going to use those. And then I'm just going to map it to some method that some ugly SQL stuff in here. So that will basically update my MySQL database. Anything else interested? Oh, yeah. Of course, I have to sort of, if I stop the application and start it again, I don't want to reprocess all the events, right? I only want to process any events that I haven't processed yet. So I have to remember what was the last event I processed. So I store an offset as well, right? So I have to read this offset first. I have to see what was the last event I got. And then I start from this offset. So I'm going to write to a MySQL database. As I said, I created this little database schema. So I have a table for the league. Pretty straightforward, the team, the games played, and the points. And for sort of this offset functionality, there's a table to store this offset. I would say, OK, this is for my league projection. The event tag I'm using is this one. And because the events are stored in Cassandra, they're going to be stored with a time UUID offset. So I have a column to store this time the last offset. I haven't processed any events yet, so there's nothing in there. And then I create an actor that does this. So I'm just going to restart my application now. What's it doing? Paste and Cassandra. OK, it has to recompile this one class, but I made this little change. So what we hope to see now is that it somehow populates the MySQL database. OK, there's already some offset in there. Oh, yeah, this is my league. Right? So now this is the view where I wanted to get to. Right? This is the sort of the 18-team table, the number of games they played, and the points that they've accumulated. So this doesn't look like much, but one thing, there's some nice things about this. So we have this completely separated, for example, and I only added this read-side processor sort of after we recorded all the events, right? Sort of, I kind of went back in time and replayed, sort of consumed these events, although this read-side projection wasn't even there at that time. So I could create another projection. For example, in Germany in the 90s, they changed the rules of the scoring. You used to get only 2 points for a win. Now you get 3 points. So maybe I want to do historic comparisons. I want to say, OK, if the old rule would still apply, would it end up with the same ranking in the league? So I could write another projection now where I only give 2 points for a win and reprocess these old events, even though I might not even have thought of this use case when I started recording these events. So I can go back and create new projections. And obviously, this is totally unrelated to the structure of this and everything is totally unrelated to my event store. So I can create all sorts of different sorts of projections for my use cases. I can create a table only representing the home games or the away games or whatever, get all these views without having to touch my event logs. Because the events haven't changed, right? The game was played, that was the result. But now I can create all these different projections. And of course, I can also completely scale this. Obviously, these are completely separate databases, right? There's the Cassandra, in this case, for the journal, for the event journal, and there's the view side, in this case, MySQL. So I can scale these. Because this is only going to be used for reading, I can just add as many replicas as I want, scale this out. Yeah, that's basically how Lagom works in CQRS terms. Stream of events. So Lagom, as I hope you got the impression, it's really simple to do this with Lagom. Lagom's great, but event sourcing and CQRS is even greater than Lagom. So even if you don't want to use or can't use Lagom, there are other things you might want to look into. Oh, this is, sorry. Oh, we're running out of time, and I don't know how to stop this now. I showed you the code. So there are other CQRS frameworks or event sourcing frameworks for Scala. So there's Aggregate Persistence. Lagom actually uses Aggregate Persistence. It's the engine underneath Lagom, but you can also use Aggregate Persistence directly. It's a bit less structure. It's a bit less type tracking in it. You have a slightly different terminology. You don't define command handlers and event handlers, but you have your receive whatever, and you have the receive restore. And you don't have these sort of predefined read-side processes. As I said, if you just use one data store, if you just stick with Cassandra or relational database for storing, then you can just use the pre-built read-side processors in Lagom. In Aggregate Persistence, you basically have to do it like I showed here with the persistence query and mapping these events yourself. But in terms of scalability, of course, it's all the same as Lagom because it's the engine underneath Lagom. There's this other framework called CQRS that has a similar approach in terms of it's a DSL on top of Aggregate Persistence. It's a sort of an abstraction layer on top of this. You can also, it has different backends. You can also use this within, if you're not even interested in long-term storage, but I don't know if that's really event sourcing still then, but you can also use it with an in-memory backend, but theoretically you could use any sort of backend there. Well, because it uses Aggregate Persistence, you can also use different backends with Aggregate Persistence, so there's a lot of flexibility there. It's Scala only. In Lagom, sometimes Lagom seems a bit noisy API-wise. I think a bit of that is caused by it being cross-platform because it's a Java and Scala framework, while this is pure Scala and tries to sort of be a bit more idiomatic Scala-wise. Has a nice website, and the creator of this framework is going to talk about type safety and messaging and event sourcing in the next slot in rooms A2, A3. So I can highly recommend going to that talk. And lastly, there's Eventuate, which does not use Aggregate Persistence. It has a slightly different approach. It has the same capabilities in terms of event sourcing, but it has an interesting, I haven't actually used it sort of, I looked at it, but I know about one thing that is an interesting difference to Aggregate Persistence. I told you that in Aggregate Persistence, if you have your key and you get this actoref or you get this persistent entity or whatever, there's always only going to be one instance in the cluster, right? So it's going to be, in terms of boundaries, you have this is always going to be consistent. In Eventuate, you can actually have multiple instances of an entity in your cluster. Why would that be a good idea? Well, this can actually be interesting if your cluster spans, say, multiple data centers, for example, and you have a slow connection. That's Acker cluster sharding it's currently not a great solution for this. You could have if you have a cluster that spans multiple data centers with a slow connection, that doesn't really fit into this philosophy that you sort of have this homogeneous cluster where you can just freely sort of put your actors wherever you want. So this can be very interesting for this, but then of course you need to define convergent rules as well. They can diverge, and they have to converge again in terms of state. So you cannot just do anything there with any actor. But it's definitely interesting, so you might want to have a look at that. I mentioned that. So, yeah, of course, everything comes at a price. Or, well, I don't know, but it's really, in some ways, it's really straightforward, the whole event sourcing thing. But of course, this whole rethinking thing also means not only unlearning things we learned, but also think about things we maybe didn't have to think about that much before. For example, if I say the events are immutable and live eternally, I'm never going to delete them. That means also I kind of carry them around forever, right? Maybe maybe my events change and my application changes and I expand my events and I have new events, but I still have to be able to process the events from whenever I started with this and created the first, because they're still going to be there. Of course, technically, there's always ways around it and so on, but it's a kind of a long-term commitment thing. Consistency, sort of, you looked at the aggregate, that's fine. It's sort of, you always know the latest state of the aggregate. It's completely consistent. The read side, as you saw, the read side is updated with the stream thing. So the read side is going to be delayed. Right? You cannot really make validation decisions based on the read side because the state might have changed already. Does that make sense? Right? So there's a delayed consistency there, or eventual consistency, as people say. And with all this messaging, message processing and things that might get lost and so there's no, in any distributed system, but you don't really have an exactly once delivery guarantee. And it's the same with the, in Lagom, I didn't really show this, but when I stored the data and the offset, I did it in one transaction. So with the relational database, okay, I will only update the offset when the data was written successfully, so I will just, if it crashes, I can just repossess that event. Depending on what store you use, you might not have these guarantees, and you might end up in a situation where you have to process, or where you can get into a situation where events are published multiple times, and you have to be able to deal with that. It's always good to have some idempotency. They have an idempotent receiver that can handle this. So, but these are things you need to start thinking about, not only with event sourcing, but with distributed systems in general, obviously. Summary. Oh man, there's another slide. So unlearn, forget about sort of this whole relational model thing. Don't focus on the static structure of the application. Think of events, of the dynamic capabilities of the application, of the flow of events. Use event sourcing. It's great with the actor model. It's a great alignment, no mismatch there. It scales great. It preserves all information. It's super flexible. And Lagom is really a great framework to get started with it because it gives you this structure, as you saw here. It's a very clear mapping, command, event, state, actor, aggregate, is persistent entity. So it's like brainless. You can just you can focus on the actual business logic and what you want to do with your events. Don't have to focus on the mechanics of it. Yeah, that's it. So we have a couple of minutes for questions. Oh, that was quick, yeah? There's somebody who's going to give you a microphone so the question can be recorded as well.
Thanks for your talk. I have the following question. I dare to say I'm a seasoned Lagom Persistence developer, so I've seen all the corners of it. What I found particularly difficult is when your business problem is inherently relational, meaning that you have relations between aggregates. So if I change state in one aggregate, can cause state changes of n other aggregates. And to keep consistency there, yeah, I find hard.
Yeah.
What would be your advice to deal with this problem?
As far as I know, there's really nothing in the framework that helps you with that, right? There's no, so in design terms, you enter the area of sort of process managers and maybe sagas and things like that. So you need some sort of coordination for this process, some entity that knows what the steps of this process are, or what you call this relational nature, what the relation is between different aggregates. So yeah, you add some, I think there are sort of well-established design patterns for that. Somebody said, I think James Roper said, there's no point in creating like a process manager in the framework because it's always so use case specific. There's sort of in terms of mechanics, there's not much you can give to the user to do it automatically. But I think these will be the patterns you would look into. It's definitely solvable. People end up with these problems, but you're right, there's nothing in the framework. As far as I know, also not in Lagom, nothing built in for sort of, in terms of process managers or things like that, right? Yeah.
Hi, thank you for the talk. Are there strategies for dealing with particularly large logs where the replay time may just end up dominating, or is this pattern primarily for smaller data sets?
No, the data can be, so the restoration is sort of sped up through the snapshots, right? So you don't, even if you have a million of events, once you snapshotted it, you will always start from the latest snapshot. And if you snapshot every 100 events, so it's never going to be more than 100 events. Of course, you can configure that. Yeah, so that shouldn't really be a problem. If you have a vast amount of data, like you use event sourcing for something that creates thousands of events per second or whatever. Well, there are use cases or weird use cases where it makes sense to use event sourcing, maybe in some sort of traffic sort of scenario where you want to keep, you have a lot of moving parts, literally moving parts, like cars and trains and so on, you want to keep track of them, but only over periods of time, so they are kind of stateful. But at some point when the train arrived, you can also throw the state away again. So there can be sort of corner cases where you say, this whole keeping the history for all time doesn't really make sense to me because this data is only valid for a certain amount of time. Of course, then, yeah, technically you can always also delete things, right? It's not, It's not magic there. It doesn't say, if you do the delete command, it doesn't say, oh no, I'm an event, I'm eternal. But the idea of event sourcing, of course, is to keep this log forever. Yeah. Okay, yeah, up there. Maybe if somebody can get a mic there. Oh, well, or maybe just one more. Maybe it's an interesting question. I can just shout it to me and I'll repeat it.
Yeah, I was wondering, you are designing an API, and that's a REST API, like REST. And but you also want to use event sourcing. And if you have a resource which should be updated, and you know it's REST and idempotent and everything, but then you have to
Oh, we're out of time. Yeah, sorry. Yeah, but that's a big question, right? So also REST is sort of it's a well-defined term, but people use it in a very vague way. But it's definitely, it's not. I think it's not a huge mismatch there, right? It's sort of course, you can still do the things you can do. I mean, this was a sort of very simple REST API with the post and the put, and you can put things and change data sort of in terms of what the user perceives, but in terms of what happens to your entity, you have to sort of map this to events. But there's absolutely no contradiction there. Of course, I would think that, I don't know how RESTful they all are, but sort of 90% probably of the systems that are built with event sourcing and use this will expose some HTTP something API. So of course that's possible. Yeah. Yeah. I'm going to be around. Thank you very much.